Okay, let me share my screen. Dun, 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 So, guys, the question that we are about to solve in today's Leetcode POTD is that there is an array that is given to us, as you can see in this case, and we have to find the longest subsequence in this array such that that subsequence should be the greatest one, like it should be an ascending order sequence. Now, what does this mean? Let us assume that this is our at the moment array that is presented to us. Okay, now if you pick the element 2, 3, 7, 101, we can say that thing, or 2, 5, 7, 101, then these are the one that are representing us to be the longest sequence sub array in this problem. Now keep in mind one thing, that we cannot actually sort this one and just return the answer, because that would result us into having an subarray or subsequence which would be equal to the size of the array that is presented to us. We can't do that thing. So now the question rises, like how we are actually going to find that thing. So see guys, this problem is basically a problem of recursion, and when we are going to apply the recursion, yes, it is going to solve some cases, but we will get TLE, the time limit exceed error is the thing that we are going to get. So to deal with this time limit exceed error, we are going to use dynamic programming in this question. Now, before we go in depth about how this code will look like, which we are going to do in this section, first of all, let's just understand that what would be the basic principle that we are going to follow in order to solve this problem. See, at any given index, let me just copy this one out so that it would be easy for us to solve this problem. So let's just do it here. Yeah. Okay. Now this is the subarray. Okay. At any given moment, the approach that I am going to choose or I'm going to take in order to solve this problem is that at any given index, these are the index that are presented to 0, 1, 2, 3, 4, 5, 6, and 7. So at any given index, either I am going to pick this element or either I'm just going to ignore this element and move forward. So now, if I'm going to pick this element, I'm going to consider it as taken, and if I'm not picking the element, then I'm going to consider it as not taken. Like I'm not picking this element, man. Just keep moving forward. That is what I'm doing here in this case. Okay. Now, when I am picking the element, it means that I have considered 10 in my sub array. And when I have not picked the not taken or not considered the 10th element, still my answer right now is empty. Now this is the approach that we are going to apply in this question. Now let's just do a dry run on this problem. Okay, so we are going to apply the principle of what? At any particular index, we are going to apply the principle of either we are going to take the element or either we are not going to take any element. So now let's just move forward. So initially we are at index 0. Okay, so at index 0 we can do two choices. Either we can pick 10 or either we can just simply move forward and have our this full subarray empty. Then as we move forward, we will move to first index. Now here I have again two choices. Either I can pick the element, either I cannot pick the element. Now one thing to keep in mind in this section, if I have picked the element, then the next element that I can pick according to the question should be greater than the one that I have picked in this case. And if we see for 9, 9 is actually smaller than 10. It is not actually greater than 10, but we need values those are greater than 10. So we are simply going to ignore these values. So in this case, in our 10 scenario, for the value of 9, we are not going to pick anything. Okay, so we are not going to consider that we are picking anything. We are just saying that, what, I haven't picked anything. Now, in this section where I haven't picked anything till the moment, what we are going to do, either I can pick 9, either I can take 9, or either I can just leave it empty. Then the same thing in here, as it is already cut down, so we are simply going to block this code. Then we will move forward, and now we will reach at index 2. So at index 2 we will have value which is equals to 2, which again is smaller than 10. So we cannot consider this value. So we are simply going to ignore this value. So here we will simply have 10 our answer, and this is for value 2. Now for the case of 9, same thing is going to happen. 9 is actually greater than 2. So we can't consider this value, as we want to have a subsequence which is farly greater. So in this case, we are not taking anything. So our subsequence still now has only 9. Now in this case, when we doesn't have any element, what we are doing here, we are actually pushing 2 or just taking it as empty. Now this is the thing that we are getting after the second iteration. Okay. Now by moving forward from here, the next element that we have is what? 3. At index 3 we have 5. So now we are going to apply this logic for 5. As you can see, 10 is greater than 5. So simply ignore this value. We can't take this value. So here I am not taking anything and just moving forward. Simply for 9, we can't pick this value. So simply just do not take any value and just move forward. Now, here comes the important part. Here our value of current last element that we have picked is 2, which is actually smaller than the value of the current index element, which at the moment is 5. So in this case, you can see that 5 is greater than 2. So here we are going to pick 5. So you can see here our subsequence now become 2 and 5. And again, not taken would be that I'm not picking anything, so I'm just keeping it 2. Then again, we have here the empty array. So either I can pick 5 or either I can just simply ignore it and keep it empty. Okay. Now, as we further move down this question, ultimately we will be at a stage where we will have subarray of 2, 5, 7, 101, or 2, 3, 7, 101, something like that. These are the two one that we are going to get when we are going to go down this recursive call again and again and again and again. And ultimately, we will have a result that we want, which would be our given thing. So this is the logic that we are actually applying in order to solve this problem. Now just keep in mind one thing, that why we are going to get TLE in this question, why we are going to get time limit exceed error in this question. See, currently the time complexity of this whole parameter that we have been given here is, let's just assume that the size of our given array is 8, and with the rate that this array is increasing, here it was 2 key power 1, here it is 2 key power 2, here it is 2 key power 3, here it is 2 key power 4, and it is going to keep increasing and increasing till it becomes 2 key power n. Now this is a complexity that we simply want to ignore. Why so? Because in an speed graph, if you see, the complexity of linear one is this one, O of n. The complexity of n log 1 is simply a little bit greater than the O of n1. So here is O of n log n. But the complexity of 2 raised to power n is something like this one. You're seeing we haven't even moved any value, and we are literally at the top of the mountain at the moment. So we don't want to deal with these situations. So now the question rises, like, how we are actually going to deal with this TLE problem. So guys, this is where dynamic programming came into play. See, when we make our recursive call, as you can see here, we are making our recursive call. We are going to get some situations at a given level such that they have similar value. What does this means? Let's just say that we are at these level. Okay. And I'm getting value 2 here, I'm getting 1 here, I'm getting 3 here, and I'm getting again 2 here. Then I move forward here, and here I'm getting 1, and here I'm getting, let's just say, 2 and 3, and here I'm getting something like 4 and 5, and again here I'm getting 1 and 1. Now, if you see carefully at this level, I have calculated for 2 one time, and again I am calculating for 2 another time. So what we can do in this case is store the value of every index, every row wise, store this value answer in a certain data structure. And whenever in my recursive call I find a value which is asking me to compute the answer which we have already done in this recursive call, as you can see in this case here 2 is asking us to do a recursive call of it when we have already done it here. This is where we are going to call this data structure and just simply return this value. So what this thing is going to do is it will simply remove every barrier, everything that we are going to face. Here, see, at the value of 2, we have already gone down the drain and we have calculated these values. And let's say we get these value. Okay, and I store it in my data structure. Now, once again in my recursive call, when I again find 2 at this similar level, what I'm going to do, I'm going to look at my data structure that, hey, have I computed this value earlier? And it is going to say, yes, you have. So what I'm going to do, rather than going downward, I'm not going to go downward from here. I'm going to simply pick the value from the data structure and return from here. So as a result of which, this actually reduces my time complexity. And if we apply the DP logic carefully, we will have a time complexity which is less than this one. And this is the optimal one that we can get in this case. So this is the logic that we are applying in this case, guys. Now you're going to ask me that, hey, you haven't taught me or you haven't explained every single thing about this question. But if we do, it will be a long and lengthy process. And before you understand, I think you should have a like little bit understanding about what is DP and how it is done. But if you guys have an understanding about it, you will be able to understand it, what is the thing or what are the terminology that I am using at this moment. And it is actually not a worry. If you don't know anything about it at the moment, you will learn with time. So to conclude this whole explanation, what we are doing here is, this is our given array. Okay, so this is our given array and we are just applying a logic of taken and non-taken, in which either I'm picking the value at a given index or I'm not picking the value and simply moving forward. And after that, at the final level, I am returning the answer that I want to achieve. Now, by solving the question via this method, we are going to get TLE, time limit exceed error. This is where our DP came into play. Now the question arises, how DP is actually going to help us reduce the time complexity? Because that is a simple question, and that why are we even applying DP? So you can see in this case, here I have calculated a value, and if I am asked to calculate the similar value again in my recursive call, I'm just going to ask my DP array to find the value if we have already calculated. And the DP array is going to say, you know what, we have already calculated. So simply I'm going to pick the value from my DP array and return from here. I won't move forward. This is the thing that we are going to do. So that is the whole explanation regarding this problem. Now let's just move on to how we have actually typed the problem. So see guys, as I already told you, the principle is taken and non-taken. That is the simple logic that we are applying in this question. Now, the first thing that we have done in this case is we have taken the pre-index value. Now, what does this mean? That what is the previous value that I have picked, which simply means that, as you can see, previously I have picked what? 10, previously I have picked what? 9, previously I have picked what? 2, previously I picked what? 5, previously I picked what? 5. This is the data structure. This is an integer element that is storing the value. Then here I have declared my DP array, which is very important in order to solve this problem, because otherwise you will get TLE error. Then I am here calling my what? Helper function. Now in my helper function, what I'm saying that if the value of current index has already been calculated, just simply return that value. There is no need to move forward. Otherwise, there are two choices that we are going to make. Either we are going to pick the element, which means not taken, or either we are going to take the element. So when we are not taking the element, we are simply calling the other recursive call without making any changes. But when we are picking the element, we are here checking if the condition is met, and if it is met, we are moving on with that call. And finally, we are returning the maximum value of whatever the call that we are going to get. And if we do it correctly, we are going to get a very respectable solution. So now let's just submit it out. As you can see, it is working perfectly fine. So guys, with that, today we have solved the Leetcode GUI POTD. Now let's just move on to the GFG one. So guys, this is the problem that we have been provided here. Now, in our GFG one, this is a very simple problem if you understand it carefully. This is a road, okay, and these are the plots that are available on the side of the road. These are the plots. Let's just assume that the number is 3 at the moment. Each side we are getting 3 plots. Now they are asking us to create combinations out of these plots. The condition is that no two building can be adjacent. That is the condition that they are providing, that no two building can be adjacent. This is the thing that we cannot afford in this case. So now the question rises, like how we are actually going to solve this problem. So now if our value of pen, if our number of plots are 3, how we can actually arrange the buildings in such a manner that no two buildings are adjacent to each other. And if you look at carefully, the structure or the permutation would look something like this, like building space space, then space building space, then it will be space space building, and then it would be what, space space space. Now here space means that I am using, or I am saying plot, that I have not built any kind of building on it. And when I'm saying B, it means that I am building a, I'm talking about a building here. Okay, now this is for the one end of the street. These are the 5 combinations that we are getting for one part of the street. Now this is our street, as I already told you, and here are other plots that are also available in this street, and these one are also going to have the similar combination. So here will be building space and building, and then again we'll be building space and space, and then space space building, then will be space building space, and the last and not least space space and space. Now just look at one thing. If I have the first row as this one in the left side, what are the number of combinations that the right side would have? As you can see, there are 5. So that is, for this first value, we are getting 5 combinations with which I can put houses in the next side of the street. There are total 5 arrangements that I'm getting. Same goes for the second one. If we pick the second one, we are going to find that there are 5 arrangements with which this one can be established, or this row can be established in the street. Same goes for the third one. There are 5 ways. Same goes for the fourth one, and same goes for the fifth one. So ultimately, our answer would be whatever the number I am getting in this side, whatever the number I am getting in this side, and just multiply them. Ultimately, it would be 25. That would be the answer that we are getting. And as you can see in this case, when our n was equals to 3, that is what we have taken in that case. The answer we are getting is 25. Now let's just understand this question more clearly. Whenever n is equals to 1, what would be the answer be? So it means that we have only one plot. This is our road, and we have only one plot on the other side. Now for this one, there are 2 combinations that can happen. One would be that either it is a building, and the second one would be either it will be a simple space. Now on the other side of the building, for the building one, there can be 2 arrangements that we can form. First one, it would be that the other side of the street has a building, or the other side of the street has only a plot. For the space or for the plot, there are 2 arrangements again. Other side of the part can have building, or the other side of the part can have space. So ultimately the combination that we are going to get in this case is building building, then is building space, then for the space one, that space building, and then the space space. And you can see the answer that we are going to get in this case is what, 4. And that can happen if we just find what are the number of combinations that I can generate on one side, and then simply multiply that element. Here I'm getting 2, just multiply it by 2, and that would be our answer. As you can see in this case, it is 4. The same thing we have done in this case. Find the number of combinations that I can get in the left side, just multiply that number with itself, and that would be our answer. This is the nativity, or the basic thing, that how or what is the logic behind this problem. Now let's just move on to solve this problem and get done with it. So the way that we are actually going to do this problem is similar logic. Like we are going to apply the similar logic in this case, and it would be recursion. And then the recursion will give us time limit exceed error, and then we will apply dynamic programming to had deal with our time limit error that we are getting at the moment. So now the question arises, like how we are actually going to apply the recursion in this case. Again guys, same principle we are going to apply. Either we are going to pick the element, that means taken, or either we are not going to take the element, so that means not taken. Now let's just draw the structure so that we will be able to understand it. Okay, now let's just consider the building to be 1 and plots to be 0, or let's say spaces to be 0. Okay, now we will create a flow chart so that we will be able to understand it, and then we will just directly move forward to the code. So initially I am at the first index. The value of n that is given to me is what, 3. So initially I am at first index. I can have two choices. Either I can pick 1 or either I can pick 0. So I pick both. Either I pick 1, either I pick 2. Now the second thing is that once I have a building, the condition they have provided me that once I have a building, I cannot have an adjacent building. So this thing cannot happen. So the only choice that I have here is that I can only have a plot here. That means I can only have a plot here, building with plot. So thus I do not have two choices in this question. I do not have two choices. I have only one choice, and that is only pick the 0, only pick the plot. But when I have only space, when I have only plot, I can either choose building or I can either choose a plot. So in this case, we have two choices. Either it will be 0, 1 or either it will be 0, 0. Then again, here I have a space. So when I have a space, I can choose anything. Either I can choose a building or either I can simply choose a space. So you can see in this case, we have two choices. 1, 0, 1, that is I have chosen the building, or 1, 0, 0, or I have just chosen the space. Now in this case, we have here the building. There cannot be another building in this case. So what we are going to do? We have only one choice in this case, which would be just choose the space. But in this case, we have two choices. It will be either 0, 0, 1 or either it will be either 0, 0, 0. Now, at that moment, the size of my whole structure in this case was 1. The size of my whole structure in this case was 2. The size of my whole structure in this case is 3. So once I make those recursion call, I'm going to get this kind of like structure. And once I reach the value of 3, that is what we want, I'm going to simply return the number of things that I am getting from my recursion call. And in this case, there are total of 5. So I'm going to simply return this value. So it will be 5. And then the answer of our answer for us in this question would be that 5 multiply 5, which would be 25. And again, to sort out the time limit exceed error, we can use a DP array, which will store the previously stored answer so that we don't have to face with those difficulties later on in our problem. So now, simple logic that we have employed in this case is what? First of all, just understand it. This is the problem. These are the houses. These are the blocks. Now, you can either place adjacent, you cannot place adjacent house, but you can place adjacent plot. So we make an arrangement out of it and we get 5 arrangements. We multiplied it by 5, we are getting 25 arrangements. Then we calculate that how we can actually generate those 5 arrangements. So we do that by recursion. So after doing the recursion, there can be TLE error that we can expect. So to deal with that, we use dynamic programming. And with dynamic programming, we would be able to solve this problem. Now let's just see that how the code would look like. So guys, what we have already done here is first we have declared the DP array, then we have declared a previous element, that is what is the element that we have previously taken. Either it will be 0, either it will be 1. If I have picked 1, then I cannot move onward with 1 again, so I have to pick 0. Then again, this is our answer. Okay, now here I am calling the helper function. Now let's just see that what will helper would do. In our helper function, I have taken two elements. First one is 1 and the second one is 0. Okay, now then I have checked that if my previous element was 0, that is, if my previous element was 0, that is, it was a space, then I have two choices. That is what I have done in this case, guys. See carefully. I have taken two choices. I am picking 1 and I am picking 0, which can be seen from this part. I am picking 1 and I am picking 0. Now, if my previous is equals to 1, which I have done in my else case, I am only picking 0. And finally, I am just returning the number of things that I am getting. That is, either it will be 0, either it will be 1. I'm just adding them out to calculate the number of combinations that we are getting, and then we are simply returning it in our answer, and then multiplying the value of answer to get our final solution that we want. Now let this submit this code out. Now it is given the TLE error, which is quite strange from the perspective of geeks for geek, but if we submit it out consistently, sometimes the code gets submitted, sometimes it just gives TLE error. But ultimately, this is the perfect code that you can get from this problem. So guys, with that, today we have solved both GFG and Leetcode POTD. We hope that you guys be able to understand it and be able to now move forward to solve the problem. With that, over to you, Shiva.
So yeah guys, thanks for joining with us. We will catch you up tomorrow. Take
Yeah,
care
guys.
guys.